So let us quickly work through question 1 in this booklet. So here in question 1 you're given a binomial expansion, and it's in ascending powers of x up to the term x cubed, which is given here. So first we want to find the value of k. So root of 1 plus kx can be written as 1 plus kx to the half. And you should have recalled the general form for the binomial expansion. I'm going to just quickly write it here so that you can remember that. That's the general form. So this one is going to be very simple. So what we have there is 1 plus kx raised to the half. In this case, n is a half. So we just simply apply ourselves here. So we would have 1 plus a half times kx. Plus n is a half factorial. There is just going to be 2, so times by a half, and then x squared there is going to be kx all squared. Final bit now, which and so on. The final bit there is going to be a half tidying up this. What we have is 1 plus a half kx, and then this is going to give us minus 1 over 8 k squared x squared, and this is going to give us plus 1 over 16 k cubed x cubed, and so on. So this should be equivalent to what we have worked out. So it means that we can write 1 plus 1 over 8 x plus a x squared plus bx cubed. So it means that this term here should be equivalent to this term here. Now it says find the value of k. So part A, let's just write that A. We want to find the value of k. So it means that a half kx, a half kx should equal to a half 8x. I mean half 1/8x. So it means that k from here would equal to 1/4 because the x there would cancel out. K is 1/4. So k is 1/4 there. Now let's look at the other part of the question. We want to find the values of the constant a and b. So again, we know that a, this x squared here would cancel out anyway. So a equals to, let's write that. So a would equal, that's part 2. That's part 1. So a is equal to minus 1/8 k squared. We already know that k is 1/4, so we would have, that would imply that we would have minus 1/8 times 1/4 squared. Which gives us minus 1/16 times 8, that's 1/28. So a is minus 1/128. Now let's work out b. So this term here, the x cubed would cancel out, so b is equal to 1/16 k cubed. So b equals to 1/16 k cubed, which implies I would have 1/16 times 1/4 cubed. And upon working that out, we get, let's see, 64 times 16, that's 1024. So b equals to 1/1024. So we have found the values of a and b. And part b now, it says use the approximation to find, use the expansion to find an approximation for the root of 1.15. So part b. We want an approximation for the root of 1.15. But this can be written as, that's the same thing as 1.15 raised to the half. But we know that, so, but we have 1 plus kx to the half. So it means that kx here would be 0.15. So it means that kx equals to 0.15. So what we're going to do is to use our binomial expansion that we work out here to get an approximation. So it means that we would have 1 plus kx to the half. We know that it is equal to 1 plus a half kx minus 1/8 k squared x squared plus 1/16 k cube x cube. So it means that we can substitute 0.15 in this. So what we have is 1 plus a half kx is 0.15, so half times 0.15 minus 1/8 times 0.15 squared plus 1/16 0.15 cubed. Let's get our calculator and input this value and see what we get. So what we get there is, we want our answers to 6 decimal places, so it means that our 6 decimal place will be here. So what we get is 1.07238 to 6 decimal places. So here ends question 1.